I go back to where there was ultraviolet erasable memory, and every time you made a program change, you had to erase your memory in a little quartz window in a ceramic.
Right.
So you saw how good flash would be way back in the early 90s. You guys had that figured out?
Yeah, so Atmel has done a lot of innovations in the microcontroller market, and at that point in time had C51 based flash microcontrollers, as you know. And with flash being the real strength of that, coming from being a memory company at that point in time. So obviously that was something we all saw, Atmel saw, and we saw that this is going to be crucial for fast development, easy development, fast prototyping, reducing the time cycle to get your product finished and out in the market.
So Atmel's memory products were known for being very, very low power. Were you concerned about power consumption from the very beginning, even in university?
It was partly something we were cautious about, even in those days. I would say that the real emphasis there comes more on the system design and the peripherals and the power management and the structures you do to that, which came very much as part of the first Atmel implementations, where battery-powered products and ultra-low power was a key requirement and key design goal from day one.
Okay. So you joined Atmel and then made some hardware. I see a little plastic box over there. Is that some of the first AVR processors in history?
Yes, I brought a case here with some of the first jewels of what we made. We have a little bit of a collection. The very first device which was the S1200, we got 10 ceramic prototypes made very fast assembly over the night. So one of these 10 has made it to my box.
So this is one of the first 10 Atmel AVR microprocessors in your hand right now?
Absolutely. So this is one of the 10s. And then we got proper plastic prototypes in a couple of weeks after, which here is actually the number one we used, as you see on the mark. Which we had in the labs.
I should mention, for semiconductor companies, a ceramic package had a hollow cavity, so you could put the die in and bond wire it out and get started right away. The plastic, then you sent that off to an assembler and they molded it on a lead frame, and it took a little longer. So.
Right. And dual inline packages, DIPs, were popular in the 80s and 90s. And the biggest one in the first family we made of 4 devices is the 8515, where this is the number 1 real sample as well. As you can see, it's revision B, where revision A didn't make it to the fabs.
Oh, in tape out or something, you found some problems and fixed it.
Right.
That's the semiconductor world.